Good day, class. This is Sir Emilio T. Tare Jr., and welcome to our sixth day of mathematics class. Today's learning objective is to find the missing term and number of terms in an arithmetic sequence. Let's have this activity first. Aya the Eye Monster. This is Aya, the cutest monster on the universe. Each year, the number of his eyes increases, as shown below. How many eyes can he have on his 12th year? If the maximum numbers of eyes he can have is 33, how many years can he live? So this problem has two questions, and the first one, we have to identify how many eyes will Aya will have on his 12th year. And on the second one, how many years before Aya can have 33 eyes? If it's the maximum number of eyes that can he have. So let's put it on a table and see clearly our data. On the first year of Aya, as you can see here, he has only one eye. And on his second year, he has 3 eyes. Third year, fifth, fourth year, seventh. And the image below only have data for until fourth year. But I added fifth year here because we clearly see a pattern on our number of eyes. So the number of eyes are 1, 3, 5, 7, and I added 9. Why? Because clearly this is an example of arithmetic sequence where the common difference is equal to what? Very good. The common difference is equal to 2. It has a consistent difference. So 3 minus 1, 2, 5 minus 3, 2, 7 minus 5, 2, and you will just add 2 to 7 to get the number of eyes on the 5th year. So our sequence again is 1, 3, 5, 7, 9, and the last term will be 33. Why? Because it is the maximum of number of eyes that Aya can have. So year number and the number of eyes. So as stated, it is an arithmetic sequence and the common difference is 2. So in arithmetic sequence, we add the common difference to a term to get the next term. So just like here, the first term is 1, we added 2 to 1, that's why we have 3. To get 5, we added 2 to the second term. To get the fourth term, we added 2 to the third term. To get the fifth term, we added the common difference or 2 to the fourth term. So, since every term of an arithmetic sequence or we added 2 or the common difference to each terms, we can rewrite it using the first term and the common difference. So we have here the first term is 1. The second term, we added 1 common difference, which is 2. The second term, we added 2 to the 2 common difference to 1, and 1 is the first term. So take note of that. And first term added 3 common difference will make it the fourth term. And to get the fifth term, we added 4 common difference to the first term. So we have here the number of i's and the number of years. The number of years will be n and the number of i's will be the a sub n or the terms. So again, pag sinabi natin n, ito yung kung pang ilan yung isang term. And yung number of i's, yung a sub n naman, ito mismo yung term. So as we can observe here, on the first year, I added another table wherein we can see how many common difference we add to each term. So on our first term, we add 0 common difference. On our second year, we added 1 common difference. On our third year, we added 2 common difference. That's why we have 2 here. On our fourth year, we added 3 common difference. That's why we have here 3. And on our fifth year, we added 4 common difference. So, observe the relationship between the number of years of our n and the number of common difference we add to each term. So, in first year, 0, second year, 1, 3, 2, fourth year, we add 3 common difference, and in fifth year, we added 4 common difference. So, what does this mean? So, to get the number of common difference that we will add in an term, to get a specific term, we deduct 1. So, from 5, we deducted 1. That's why we have 4. In here, we have 4 minus 1 is 3. So, if this is n, then the number of common difference that will be added to the first term is n minus 1. So, how do we compute for the number of i's on Aya's 12th year? So, a sub 12 represents the number of i's that Aya will have on his 12th year. 1 is the a sub 1 or the first term. 11 came from 12 minus 1. So this is the 12th year. That's why we add 11 common difference. So 2 is the common difference. So going back to 11, it came from n minus 1. So basically, this a sub 12 is our general term. And using these details here, from this equation, the formula in finding the general term of an arithmetic sequence is a sub n, or the general term, the term that we will that we are finding or we want to find, is equal to the first term a sub 1 plus quantity n. Again, the n stands for kung pang ilan yung term na gusto mong hanapin, and d is the common difference. So going back to the problem, the number of i's of Aya on his 12th year, or a sub 12, we can use the formula. So first, the term that we want to find, or our a sub n, is a sub 12. So that's our a sub n. Now our a sub 1 is the first term, which is 1. Just to go back to our sequence is 1, 3, 5, 7, 9, and the last term is 33. So from this sequence that we generated a while ago, our first term is 1. And on our n is equal to 12. since we are looking for the 12th term, our n is 12. And our common difference is 2, as we just like what we discussed a while ago. So let's substitute these values on our formula or on our equation. A sub n will be a sub 12 is equal to a sub 1, which is 1, plus n is 12 minus 1 times 2. So a sub 12 will be equal to 1 plus 12 minus 1 is 11 times 2. Now, I have a question. We have here a series of operations. So, we have here 1 plus 11 and 11 times 2. So, the question is, what should we operate first? 1 plus 11 or 11 times 2? The correct answer is 11 times 2. So using the MDAS rule in system or PEMDAS in series of operations, we operate division and multiplication first before addition and subtraction. So a sub 12 will be equal to 1 plus 11 times 2 is 22. So our a sub 12 will be equal to 23. So what does this mean? What does this our answer says? So it only means that on his 12th year, Aya will have 23 eyes. Okay. Now, for the second question on our problem, to calculate the number of years, to know when will Aya reach the maximum number of eyes, which is 33, we can also use the formula. So, on our problem, a sub n is 33. It's the last term, and we want to know kung pang ilan tong 33 na to sa ating sequence. And our a sub 1 is 1. N is not yet defined. We are tasked to find n kung pang ilang year or pang ilan sa ating sequence ang 33. And D is equal to 2. So using this data here, let's substitute it to our equation. A sub n is 33 equal a sub n is 33, a sub 1 is 1 plus n is missing. So we will maintain it as n and d is 2. Okay, so let's just copy 33, then distribute first 2 to the binomial here, n minus 1. So just copy 1 plus 2 times n is 2n minus 2 times negative 1 is negative 2. So let's combine similar terms, which are 1 and negative 2. So we will have 33 is equal to 2n. Let's just copy 2n first, and 1 plus negative 2 is negative 1. Now we have to eliminate, or we are looking for the value of n. To find the value of n, we have to eliminate first the negative 1 and this coefficient, the 2 that is coefficient of n. So let's eliminate first one by adding positive 1 to the both side of our equation. So it will be 33 plus positive 1 is equal to 2n minus 1 plus 1. So negative 1 plus 1 is 0. So what will remain are 2n is equal to 34. So 2n is equal to 34 is the same as 34 is equal to 2n. So since we successfully eliminated negative 1, now let's eliminate 2 by dividing both sides by 2 to reduce it to 1 or just n. So n is equal to 17. So what does 17 stands for? So, or what does 17 says about our problem? So Aya will have 33 eyes on his 17th year. Okay. Now that we have idea about this formula, let's use it to solve this problem. So find the 15th term of the arithmetic sequence 30, 26, 22, 18, and so on. So again, the formula that will be used is a sub n is equal to a sub 1 plus n minus 1 times the difference or common difference. So let's find out first the given. So let's find what is a sub n, a sub 1, n, and 2. So here, our a sub n will be equal to the a sub 15, or the term that we will look is a sub 15. Why? Because we are looking for the 15th term or a sub 15. And our a sub 1 is obviously equal to 30. Our n is, since a sub the term we are looking for is a sub 15, L will be 15. And the common difference is, okay, what do you think is the common difference? What can you observe to our pattern? Is it decreasing or increasing? Very good, in decreasing. Since it is decreasing, the common difference is negative. So again, kapag ang isang arithmetic sequence ay pataas, ang common difference ay positive. Kapag ang arithmetic sequence ay pababa, ibig sabihin ang common difference ay negative. So dito, our common difference is negative 4. So we subtract and subtract and subtract just to make sure that we have a constant or common difference. So now let's substitute it to our equation. A sub n is a sub 15 is equal to a sub 1, which is 30, plus n, which is 15 minus 1, times the common difference, which is negative 14. Okay. In writing a multiplier, for a negative multiplier, we should always put a parenthesis to enclose it. Kasi magmumukhang minus 4 kapag walang parenthesis. Kaya ang goal natin is to multiply it. So a sub 15 is equal to 30 plus 15 minus 1. Again, unahin natin yung nasa parenthesis, which is 14 times negative 4. So let's just copy 30 because we will operate multiplication first. 14 times negative 4 is negative 56. And let's just add them to get our 15th term, which is negative 26. So that will be the final answer. The 15th term is negative 26. Exercise number 2. In the arithmetic sequence 5, 9, 13, 17, which term is 401? Or meron tayo ditong sequence ng 5, 9, 13, 17, and so on. Kasama dun sa infinity na yon ay, or kasama sa mga susunod na term ay 401. So, merong infinite number of terms na kasunod sa 17. At isa doon ay 401. Ang tanong, pang ilan yung 401? Okay. So, using our formula, a sub n is equal to a sub 1 plus n minus 1 times d. Let's identify our a sub n. A sub n is 401. Yung term na aalamin natin kung pang ilan. So again, yung 401, hindi natin alam kung pang ilan siya, pero siya po yung hahanapin natin or aalamin kung pang ilan. Kaya ang a sub n natin is 401. Next, a sub 1 will be equal to 5, the first term. Next, n is equal to, wala pa po, siya pa po yung nawawala. Again, hahanapin natin kung pang ilan ang 401. And our common difference is, because our sequence is increasing, the common difference is positive. And the common difference is 4. So let's substitute it to our equation. We have here a sub n is 401 equal to a sub 1 is 5 plus n minus 1 times d, which is 4. So let's just copy first. 401 is equal to 5 plus, let us distribute 4, n times 4 is 4n. 4 times negative 1 is negative 4. Now let's combine similar terms on our right side of our equation. 5 minus 4. So we will just copy 401 is equal to 4n, copy 4n. 5 minus 4 is 1 plus 1. So our goal here is to eliminate 1 and 4 as the coefficient, or eliminate 1 and reduce 4 to 1, or just n. So to eliminate positive 1, we have to add the additive inverse of it to the both side of our equation, which is negative 1. Again, the additive inverse of positive 1 is negative 1 equal to 4n plus 1 plus negative 1. So kapag inad natin ang 1 sa negative 1, 0 na po yan. Ang matitira sa right side ng equation natin is 4n. Samantalang sa left side naman is 400. And 400 equals to 4n can be rewritten as 4n equal to 400. So to reduce 4n to n, we have to divide both sides by 4. So n will be equal to 100. So meaning to say, 401 is the 100 term, or siya yung pang 100 term ng sequence. So ibig sabihin, kapag nag-plus 4 ka ng nag-plus 4 sa sequence na to, 5 plus 4, 9 plus 4, 13 plus 4, 17 plus 4, and so on. Yung pang 100 na term ay 401. Okay.